6 o'clock here in Chicago, and I'd like to welcome you all to the ACM Chicago webinar this evening. So we have a ACM distinguished speaker, Ricardo Baeza-Yates from Northeastern University, Silicon Valley, and he will be talking on bias on the web. As well with ACM Chicago, we'd like to also thank the attendees from the other societies that are also here as well, that we've also invited. So thank you to members from IEEE Computer Society Chicago chapter for coming here this evening. Also thank you to members of the Mid-America Club IT Connect group. And also thank you for the support of Polymorphic systems. So just before we start our webinar this evening, I'm going to launch a quick poll that you will see. And I'd just like you to just quickly answer, just to give us an indication, how many people here are ACM members or IEEE members or none of the above. And if you work in academia or industry or you're a professional or student. Thank you. Okay, so I'll keep that poll running for other people that have joined to be able to do that, and I'll continue onward. So that's my slides. Okay, here we go. Yes, so if you're not familiar with ACM Chicago, well, first of all, ACM, if those people who don't know ACM, stands for the Association for Computing Machinery. So basically, it's a professional organization of computer professionals that hold, publications. So if you're in the academic industry or so, you can read publications from ACM Chicago. No, it's not from ACM, and also as well, ACM holds conferences. So some of the conferences that you might be familiar with is the ACM, the CHI conference, the Computer Human Interaction Conference, as well as the web conference too as well. So the Chicago, we are the Chicago chapter of the Association for Computing Machinery. And we hold monthly meetings on topics that deal with computing. And so, for example, we've had previously two ACM distinguished speakers who spoke with us in person. So you might have attended one of those particular meetups. So there was one with Hadley Wickham, Chief Scientist of RStudio. So if you use the RStudio for writing R scripts for doing statistics, he was our distinguished speaker for one of the events. And the second event that we had was Professor Tao Xian from Urbana-Champaign. And so we're very glad this evening to have our third distinguished speaker, Ricardo Baeza-Yates. So I'm the chair of the ACM Chicago. I just started being chair beginning of this month. Our vice chair is Mark Temkin, and our treasurer is Greg Newmark. You can see that on the slides here, we have our links. So if you want to follow us on the web, chicagoacm.org. The majority of our events are on the Meetup platform. So you can go to ACM-Chicago, and I'm sure most of you found it out through there. So you will see our past and you will see our future events that will be there. We also have a Facebook page that you can follow us, as well as Twitter and LinkedIn. And if you manage to be posting on social media this evening, please use the hashtag ACM Chicago. Okay, now I'm going to introduce Gina Martinez. Gina, are you there?
Yeah, I am. Thank you, Alvin.
IEEE Computing Society.
Thanks, Alvin, for the opportunity to talk a little bit about Computer Society. I'm just gonna introduce it real quickly for those who are not familiar with it. It's the primary computing related society under IEEE. The society actually runs the website computer.org, so you can find a lot more information about the society there. We typically hold monthly meetings with technical talks, with topics related to software, hardware, networking, anything related to computing. If you'd like to connect with us, our website is in the slide there. We are also on Facebook, Twitter, and LinkedIn. And we're also participating in the IEEE Chicago Expo and Fair this weekend. Alvin will talk more about that event. So thank you for your time.
All right, thank you, Gina. So we thank you for the members of IEEE Computer Society Chicago to also be on this in this webinar too as well. Third of all, we also have members from the Mid-America Club IT Connect group. So I'd like to ask BJ to say a few words about this group.
Good evening, everyone. Thanks, Alvin, for Mid-America IT Connect to co-host this event along with ACM Chicago and IEEE. My name is Vijay Konkimala. I am the founder of the Mid-America IT Connect. Mid-America IT Connect was started about 3.5 years ago to share and collaborate on cutting-edge technology. The club, Mid-America Club, is an exclusive club in Chicago, and it has beautiful panoramic views of the city skyline. So this event is our 35th presentation. Today's event is extremely relevant topic during these days and will be in future. We are excited and are looking forward to hear Dr. Ricardo Baeza-Yates, who is the Director of Data Science Program at Northeastern University, talk about bias on the web. Welcome, Dr. Ricardo.
Okay, thank you, Vijay. So I just want to add here as well that we've also had previous ACM and IEEE Chicago events at the Mid-America Club. Yes, okay, very good, thank you. Okay, and the reason why you're all here this evening, so our speaker is ACM Distinguished Speaker Ricardo Baeza-Yates. So like what Vijay said, he's the Director of Data Science Programs at Northeastern University, Silicon Valley. He's also a part-time professor at Universitat Pompeu Fabra in Barcelona and Universitat de Chile in Santiago. He was a former Vice President of Research at Yahoo. You might have heard of that, Yahoo, right? Yahoo Labs in Barcelona and also in Sunnyvale, California. If you're a student, maybe you might have used his book in one of your courses. He's a co-author of the bestseller Modern Information Retrieval textbook that won the ACIS 2012 Book of the Year. He's a very, very accomplished professional and a scientist. So he's also very, very prolific in ACM and in IEEE. So he's been part of the Board of Governors of the IEEE Computer Society, which actually I didn't know of myself, from 2002 to 2004. He was also a member of the ACM Council from 2012 to 2016. Ricardo is an ACM Fellow and an IEEE Fellow. And he got his PhD from computer science from University of Waterloo, which, interesting enough, was also my alma mater too as well. And I met Ricardo, during my time when I was in Palo Alto during my internship and also at various different conferences. So just before we start, a little bit of housekeeping rules. Please mute yourself and and turn off your video. So that way we can ensure that we have an optimum viewing watching experience. And we have a Q&A section. So you can write the Q&A in the Q&A button that you will see in the Zoom. And then we will do Q&A after Ricardo finishes his talk. Okay, and so without further ado, I'm going to stop sharing and introduce Ricardo Baeza-Yates. So Ricardo, the floor It's all yours.
Well, thank you, Alvin, Mark, Vijay, for the opportunity to give this talk. Let me. So you are seeing now the presentation, right?
We see your PowerPoint, but it's not full screen.
Okay, that's right. Okay, and now?
Yes, it is now full screen.
Okay, so I will talk about the bias on the web, and this is an article that appeared 2 years ago in Communications by ACM in June, and basically this is an enlarged presentation based on that article. And it's also based in like more than 10 years studying bias in several ways, and you will see that. So because this is a talk that is promoted by the ACM Distinguished Speaker Program, I just have this as a short slide about ACM. As already Alvin said, I'm a proud member of ACM, and also I'm an ACM fellow, and also I'm a IEEE fellow, and it's nice that it's also this IEEE presentation, because I have been a member of ACM and IEEE when I was an electrical engineering student in Chile. So this was like started, I guess, wow, more than 45 years ago of being a member. So I feel old now. So no, that's too much, 35 years, not 45, 35. And if anyone wants to organize a presentation with the Distinguished Speaker Program, you can go to this page, dsp.acm.org, and request a speaker, even if you have to travel. These days you don't travel because of COVID, but in the future you should. Okay, so let's start with explaining what is bias to make sure that you have the same understanding. So typically you can see 3 different definitions. One is the one that all people in engineering know, like a statistical bias. And this means that you have a reference value, you do a measurement. The measurement, for example, you get this normal distribution, you have an imprecision, which is the variance of the measurement, but also you have an inaccuracy. And this inaccuracy is a bias if it's a systematic deviation from the reference value. Basically, if you take your weight every day and it's always 1 pound more, then that would be a bias of the weight of the scale. But then you have cultural bias. Basically, this is what you learn from your education, from your background, even from your language. So language encodes a lot of bias already. And then part of the cultural bias are also cognitive biases, which are basically personal biases. And here there's a list of 20 very popular biases that you can find in the web. And here you have one of the main ones today, is confirmation bias. You see something that agrees with your beliefs, and then you believe it's true. And this is why fake news are so powerful, because they're basically exploiting your confirmation bias. But there are not only 20, there are more than 100 cognitive biases, and you can go and find this cognitive bias codex, which has classified more than 100 biases that the psychologists have defined. So there were 3 motivations that were different on time, I guess in a different order, but the first motivation is the inequality of content in the web. That starts with the inequality of access. For example, from Iceland to, say, South Sudan or North Korea, which is a closed country for internet, but also the content. We'll see a little bit more about that, about content and language. But for example, English is a dominant language in the web, even though only 13% of the world population speaks native English. And for example, there are 7,000 languages that are active today that are still alive, but only 5% of them have a Wikipedia. So also we are losing culture there. Another important point is that the content is optimized for local purposes, for example, for business and government, but not for content per se or for the actual needs of people. And this is important because the web, not all the web is made for you. It's made for some economic incentive. So the second motivation is the one that is more interesting for me as a professional, is what is the impact of search and recommender systems. So basically, most web systems use clicks and other interaction as implicit user feedback. But basically, that feedback is basically made partially by the algorithm because the algorithm is presenting options to you. So it's not that you can click anywhere, you can click only on what is in the screen. And we will get back to this because maybe this is the main point or one of the main points of the talk. So that creates, for example, the filter bubble problem. That creates echo chambers, not only for people, but also for recommendation systems or for even search engines. So we'll get back to that. And sometimes these systems, because they use machine learning, they're competing among themselves. For example, maybe the monetization team, every time that earns more money, is making the user experience team less successful because they are, for example, losing clicks or losing users. And it's very hard to have a single optimization function for all the things that you want to optimize in a system. And the third motivation is about this. And I think I don't need to prove that this is a fake, because there's some causality between the internet and Einstein. But many people may not know, and then they will believe that he said that. And this is the third motivation, maybe the initial one that I had, and today I started to talk about this in 2016, and it's funny that again, 4 years later, this is a very important topic, and next presidential election is this thing. And here I like to remember a quote of Mark Twain in his memoirs that he attributed wrongly to a prime minister in the UK, that he said there are three kinds of lies: lies, dumb lies, and statistics. This was said by someone at the end of 19th century, but this is what is happening. You can take data and use it as you want. And of course, bias is not something wrong. So bias is not negative. We have a bias to talk about bias in a negative way because we only talk about bias when there's a negative impact. We never talk, for example, too much about affirmative actions, which are positive bias, and so on. But we need bias to live. If you think, we need to do some systematic things that are important for our survival. So the premise is that all observational human data has bias. I stress the word observational because if you do experiments with human, maybe you can control some features, but of course, you shouldn't do experiments with humans, right? So here we can put some cultural biases. I will not read this list. You can read it. This is my own list. Then you have some statistical biases that appear in the process of gathering data, of how the data is valid on time, about web spam, and so on. And finally, we have the cognitive biases of the user. And as I shown, there are more than 100. This is too much. So we will put all your cognitive biases in one type of bias, and we'll call it self-selection. So basically, it's your self-selection bias when you interact with a computer. Now, a lot of people have worked on the main cultural biases like gender and racial bias. And then if you take Twitter data, for example, here there are 6 biases of Twitter data. There are more males, there are more young people. It's mainly in places where you have a lot of people, so east and west coast of the US, people with more education, people usually with more money, and also people that like technology. So it's not really representative data, as you don't have all users, possible users of the US. So it's very hard to make that data representative. Now, what I will try to do today is to do an unbiased view on bias in systems. And of course, this is the main point of bias that you are not aware of. So let's start with a non-technical question. You have biased data, it comes to an algorithm, the data will always be biased. I mean, uniform distribution is not interesting for anything. So there's always some kind of bias. And then you need to ask the question, should the algorithm be neutral? Should the algorithm be fair? And here is the first problem. What means to be neutral? What means to be fair? Even in some cases, so as a society, we don't agree on what means to be fair. So typically, we don't ask these questions, and the algorithm basically has the output and has the same bias. For example, if you take LinkedIn and you search for people, you will have more men than female. If you look for images, maybe you have more white people than African American people, and so on. So let's remember what is being fair, and here's a well-used cartoon about the difference between equality, equity, and justice. And for example, for equity, you do affirmative action, which is a kind of positive bias, but the solution is much harder because the solution means to get rid of the problem, and it's very hard. For example, to say, let's stop racism, that doesn't work because many people need to change a lot to stop that. So the answer, as all important problems, is difficult, is not always, but of course the answer is yes if you find people. So we need to worry about that. And there are 3 ways to solve the problem. We'll talk a little bit about those later. So, but this talk is mainly about being aware of bias, because the first step to fight bias is to be aware that you are biased. And sometimes people is not aware of that. So in 2017, ACM, more than 3 years ago, did a statement. This was the Technology Policy Committee, where I'm a member of the subcommittee on algorithms and AI, did this statement on the 7 properties that an algorithm should fulfill. So today we're talking about the first one, awareness. So the algorithm should be aware of what it's doing. Of course, there are many more, but most algorithms don't have these properties. Not even one: accountability, explanation, data provenance, like organic food. Typically not. However, they don't have to be perfect. They just need to be better than us. So for example, people really judge machines much harder than humans. And yesterday, a Chilean colleague, Cesar Hidalgo, just published a book on how humans judge machines. I'm sure that, for example, self-driving cars will kill much less people than humans, because they don't drink, they don't get tired, they don't look at the cell phone, and so on. Many things that they don't do. So in the middle of the 90s, there were some early papers on bias, but then all the work disappeared until machine learning came, and we started to see problems with training data. And one of the reasons I think that there are some problems is because we assume things like uniformity of data properties or uniformity of error. But the truth is that if you have a more complex problem, you need to put more data, unless or otherwise the prediction error will grow. Now, no one has done this study, but let's say it's something like this. If you don't have enough data, if your problem is complex, then the prediction error is large. Most papers don't even do error analysis. That's another problem. So let's start with all the biases that we can find in the web. So the first one is data bias, and I'm not talking about web spam. That I can give another complete talk about web spam. I had research on that, but these are more subtle bias. It's not like a bias that is made to deceive people and search engines. This is data encoded in some way that comes from human. So let me give you some examples. So this is from a study we did in the web of Spain, which is still the largest study web of a country 15 years ago. And these are economic bias in links. So for example, here you have exports in thousands of dollars to other countries, from Spain to other countries. From Spain to other countries. And then here you have the number of linked domains from the web of Spain to other countries. Well, you see some anomalies, some outliers, and these ones are really not countries. So maybe you can check where is TK, you can check where is FM, is related to the US. But for example, FM was a country that, well, it's not a country, a region that sold the right to use their domain for radios and so on. The correlation here is more than 0.8. We did this with 5 countries, and we show that more developed the country, higher the correlation. So that's not a causality proof, but it's a very strong indication that the economy is basically reflected, projected in the web. But also you have things like cultural bias. So here I have the log graph of the size of web pages in different countries. And you see that on the right, you have a power law kind of behavior. So basically, you have very few large pages, which is normal because you don't want to do like a 1 megabyte page. Those very large pages at the end are typically done by machines, not by people. And this is just a reflection of what is the famous law of minimal effort of George Sept on the 30s in last century. However, you see that at the beginning, there's another law, and I call it the shame law. So basically, you do a web page until you feel that you did enough, you don't feel any shame, and then you become lazy. So this is the power between shame and laziness. And this happens in many other things. For example, even for images. So for images, you see that on the average there are 3 images per page, but in South Korea, they love it. The live images, they have 12, while in Spain, they have very little. So these are cultural differences. Linguistic bias. For example, this company, Language Connect, says that more than half of the top 1 million websites are in English. I cannot audit the list of sites because we don't have it. But maybe that's true. But what is the reference value? And this is the first problem when you have a bias. What is the right reference value? You can say, okay, let's take the language that people speak. And then English is the third one in yellow there is about 10%, let's say. But people say, well, but not all that people have access to internet. Why you're taking that? Okay, you're right. Let's take only the people that have access to internet. And then English is 25%. Still, it's a big bias. But then once we're talking about content, you take people, take content. Okay, I take content, and then I get that, according to this other study, 27% is English. So it's still double more on quality. So there is a bias between English and content quality as a language in the web. I will go fast through some slides because I have more material than the time I have allotted. So this is typical problem with news. News comes from capitals. This is in Chile, so this is news coming from Santiago. So if you do your standard recommendation algorithm, most news will come from a capital. Here in the US will be the same. They will come from Washington. So this study will show that with one of my former PhD students, Eduardo, that basically people prefer geolocalization so they can see some news that are local to them, not only from the capital. Gender bias in content. It was a very famous paper in NeurIPS 2016 that they used a large collection of news from the web, and they extracted automatically she-he analogies. Like if you say queen, then he's a king. If you say sister, he's a brother, and so on. Mother, father. But most of them had the stereotypes. Like if she's a nurse, he's a surgeon. Or she's a diva, and you know there's some negative connotation to be a diva, he's a superstar. And of course, when I saw this paper, I said, okay, maybe most journalists in the US are men. And yes, I found that that's the case. About 70% of the top journalists in the US are men. But I found a surprise that it's the opposite at college. So women have a trouble trying to get to be a journalist because it's a male-dominated profession, even though they are a majority. I mean, females are a majority. You see gender bias in translation, and I guess you have seen the news about GPT-3 and basically very large language models trained on large amounts of text, mainly from the web. And then these things happen. Like, this was true like a few months ago. He's a babysitter, she's a doctor. So I translated to Turkish. I don't know any Turkish, but I cut and paste, and I translate it back, and I get she's a babysitter, he's a doctor. So 2 years ago, this was fixed for one sentence. but not for 2 sentences. So I checked today if this was fixed or not, and this is interesting. Now both are female. So they decided to do an affirmative action. When you don't know, it's always female. So, but still, this one is translated. So there's a stereotype that the babysitter has to be a female. So it's still not working completely. And this has been like a problem for Google Translate for years. My last example on content, gender bias in female biographies in Wikipedia, another work of Eduardo. So this is the number of female biographies in Wikipedia, and you see that they're going up. Interesting seems to be that the turning point was the French Revolution. So there's some interesting history comes here, but it still is not 50%. And then you can say, well, this is nothing strange, this is just systemic bias. Well, the truth is that there's a much bigger bias here, and this will be obvious after you know it, but many things that are obvious, they're obvious only after you know them. Before, they're not obvious. Well, what is the largest bias here? Well, that most editors in Wikipedia are men. So for females biographies, only like 11% are women. And this is partial information because it's not compulsory to give your gender in Wikipedia, and many women don't do it because of harassing issues. And then maybe this number is 15%. But still 15% is very far from 50%. And that's why we have bias on biographies. So the next one, engagement or activity bias. This is the bias of all the people interacting with the web. So this is our bias as a group. I will get back later to the cognitive bias of yourself. And then with another of my PhD student, Diego, we did this analysis of engagement bias on different data sets. So we look at which percentage of people produce 50% of the content. This is like the democracy of content. Of course, we are only looking at active users because the passive users, we cannot know them. It's not in the data, and only each platform knows the number of passive users. But let's say it's about 90%, roughly. So we're looking at 10% of the users. So looking at that, we have that in a small data set that was available for the Katrina hurricane. 7% of the people did half of the post. So this is what it means, this. 7% of the people did one half, and 93% did the other half, and these are only the active users. In Amazon reviews, the large collection you can download from Stanford, 4% of the people did half of the reviews. I couldn't believe this the first time, and we checked a lot of these results that were published in September of 2015 in the ACM Hypertext Conference. And I said, okay, the only reason, the only incentive that can explain this this skew distribution is that these are being paid. And I don't know if this is a causality, but 1 month later of our publication, Amazon started to sue fake reviewers. And this continued in 2016, continued 2017, continued 2018, 19, and continues today because this is a main problem for Amazon, that basically many reviews are fake. We checked the quality of those reviews, and we found this metric, text entropy, that had a high correlation with basically the number of stars in every review, or how good was the review, how useful was the review. And then this 4% went down to 2.5% if you consider the reviews by quality and not by volume. We also look at the very large collection of Twitter in 2009 that was available in Germany, almost all Twitter at that time. And we found that 2% of the people did half of the post. No surprise here, I guess there is a big incentive, it's called ego, and there are even some presidents that do tweets every morning. And finally, we look at all the data that is public of usage of Wikipedia, and we found that 2,000 people did the first 50% of entries of the English Wikipedia. And of course, they were paid. But maybe that's the reason that we have a Wikipedia today, because no one will contribute to something that is empty. You need to have at least half empty, or better, half full. With Diego also looked at a problem I was curious about, and I call it the digital desert. Basically, how much content in the web no one ever sees. So maybe you don't know how many pages there are. There are more than, basically infinitely many. There are more than 200 million websites. How many do you know? And here we look at, again, at the Wikipedia data, and we found that 31% of the articles that were added or changed in 1 month were never visited in the next month. So this was an upper bound, 31%, because of course the number depends on the period. But then we checked the content in Twitter, and we found that more than 1% of the tweets were done by people that don't have any followers. So this is like going to the Death Valley and screaming. Maybe a cathartic experience for you, but no one is listening. So that's the digital desert. So the next part of our cycle is that when you use data from the web. So you have an algorithm, you will do some bias. There are two problems here: the size of the sample and any sampling bias. So we need to check for sampling bias. And then the next problem is algorithmic bias. And here I differ from other authors. When I say algorithmic bias, this is bias that comes from the algorithm, not from the data. Most biases come from the data, but maybe you don't know examples. Some biases may come from the algorithm. I will give you some examples. So sample size, this is the first problem. And one of the issues here is that there's a bias on statistics books. They are obsessed with uniform distribution and P equals 1/2. I still haven't seen a uniform distribution in my life, only in statistics books. What's the problem? Well, in the web, we are dealing with very small probabilities, like probability of a click in an ad. And if you take the standard binomial error formula, well, this formula diverges for very small probabilities. So you need to fix that by using other methods that basically estimate the size of the sample. For example, Gresti-Kuhl interval is much better. And here you have the formula to get what is the right size. For example, here I have an example for 10% relative error, very important, relative error, not absolute error, because you're working very close to 0. You cannot use absolute error. And for a probability of 0.1 and a very bad confidence interval, 80%, we have the difference of almost 150% between one size and the correct size. And even if you use the right sampling algorithm, so the standard sampling algorithm, when you have a very skewed distribution like power laws, then you get the wrong sample. So this is an example of real query logs. And you see that when you go only to 1,000 queries, then the distribution doesn't even resemble the original distribution. So you need to do some kind of stratified sampling. And also you need to fix the tail, because the tail is not really a power law. For example, in queries, about 30% of the queries are unique if you have a mobile query law. So you need to do this stratified sampling technique, and then you can get exactly the same distribution that you had in the original dataset. Okay, algorithmic bias. Let me give you an extreme example, and then we will get to a class of problems with algorithms. So imagine you have a system where you can upload pictures, like Flickr, and you can put labels, tags. So you upload this picture of London, you put these two labels, London Eye and Thames, and then because you are a computer scientist, you know about recommendation systems, you know about quality filtering, using co-occurrence of tags, you build a nice system to suggest tags to people, and then people mark the ones that are correct. What's the problem with this system? The problem with the system is that the people will use it. So next time I will put just one tag. And if I realize that we're using deep learning, we can say, okay, why putting tags? The system already knows everything. And then there are no more tags from people. What is this? Well, if you don't have more tags from people, the system cannot learn anything, cannot improve. So this is like a very slow harakiri, and then you shouldn't do this. If you want to have folksonomy that it improves on time and allows a system to learn all the time, you cannot help people. Can you use these tags? Yes, you can do it for query expansion, for example, and then you search better. But please don't help people, because minimal effort kicks in right away and people will do less than they already do. So we're getting to the end of the cycle. Interaction bias. So this is also comes from the algorithm, but it comes with the combination of the user. So it's a combination of the self-selection of the bias of the user and the algorithmic bias of the algorithm because of where these things were put on the screen. These are very powerful. And so you understand what I mean, please read the next slides. Sorry, very important. This is about digital nudging and privacy too. So now, if anyone read the bottom of the slide, that says something I like, but many people don't reach that point. But I guess you understand what I mean now. So let's say you have this standard page, a bias query, and then what are the biases here? The first one is what's called exposure or presentation bias, which is very important in medicine. For example, in COVID, how many people have been exposed to COVID, which is different from how many people can have COVID, which is very hard to basically measure. So you can only click on things that are shown to you. And for example, the other 10 million books that you don't see, sorry, you cannot click on them. So basically you have like this, like an iceberg, where you can only click on some things and the rest you don't see it. But it's even much worse than iceberg, because basically you are just looking at the tip of the iceberg, at the ice cube. The rest you are not able to click. You have to do a scroll. And if you want to get really deep, sometimes you cannot, because you have a limit in answers or limited recommendations and so on. The next bias here is position bias, where the object is in the screen matters. For example, in the Western world, we will go first to the left top corner. In other places, we will go to the right top corner. We will go from left to right reading. Other people, like China, they will go top to bottom reading. So there are cultural biases there. Ranking bias is an example. People will click on my book, the first result, only because it's the first result, not because it's the best book. In this case, maybe it's the same, but just for the sake of the example. Social bias. For example, how many people will buy this book only based on the reviews? That means that group of people is biasing your behavior because you believe in those stars. Remember, these might be false. I don't have any false reviews because there are too little. I didn't pay for reviews. Interaction bias. Anything else here? You do a scroll. Do you look? Do you know that you can do a scroll? There are many things that may happen on the experience here. And the problem is that this is a cascade of biases. There are dependencies between them. So for example, exposure bias affects position bias, and that affects ranking bias. Everything on the left of this line comes from the algorithm and the data, and everything on the right comes from you. Some people cannot read without moving the mouse. Some people cannot read without clicking for more than 5 seconds. Some people scroll, some people don't scroll. These are cognitive biases. Here is what I was saying, a heat map using eye tracking software of where people look in a search engine. And you see that before they look on the top left corner because it was mainly text, but when universal search started and you have many types of answers, then you look at images. And then you get this. This is an example of ranking bias. You see that the number of clicks on the first result is over 40%. Well, there are two problems here. The first one is about 15% are navigational queries because of the law of minimal effort. People is too lazy to type the whole URL, they search a keyword and then click to go to the URL. But still, we take out 15%, you get something like 28%. That's more than double the next result. And this is ranking bias. So you see that this is much more skewed than it should be. And here you have another example of interaction bias. So someone said that you need to have 10 results in a desktop answer. Why 10? Why not the size of the screen? Why not like in a mobile today that it's in infinite browsing? Well, we need to talk to the first engineer that decided this in the first search engine, which is not Alta Vista. So homework if you want to learn computer history. So if we do this graph, what we want is that we have these 3 lines in a log-log graph, but we want the real distribution. We want to do this. And search engines do this, otherwise they will fool themselves, thinking that the first result is much better than they think. So there are many ways to do this. The Yahoo Labs published 3 papers on this. The last one got the best paper award at Wisdom, ACM Wisdom. But also you can try to do this on the algorithm itself. That was the best paper award on Wisdom 2017 by Thorsten Jorkins from Cornell. Or you can do, for example, fair rankings on searching people. And this is I work with one of my former PhD students and his PhD student. And why I like to put this, because this is the 3 ways to solve the problem. You can devise the input, so trying to take the bias from the data. You can tune the algorithm, basically deal with the bias on the algorithm, which is hard. Or you can devise the output, but warning, you have lost already information. Maybe you will do much worse. But sometimes you don't have any choice. For example, if you need to work with linked answers, you will need to do it after because you don't have the data. So to end, second order bias. So basically, you take the data from the web as a user, and then you do something back to the user, to the system. And there are 2 possibilities. You put information back to the web, or your interaction is used by the algorithm to personalize your experience or to give you feedback in many other ways. So let's look at the first one. Let's say how you put back information in the web. Let's say you're writing a blog. The next entry in your blog. So you do a query, you find some search results, ranking bias. You select 3 pieces that you find interesting about the query about the topic you're writing. You put them in this new page. Of course, you're not doing plagiarism, so you put a link back to the original place, you put quotes, and you put the author names because that's the correct way to do research. And now you feel some shame because nothing from you, so you put 1 piece that is yours to connect these things. And then ego comes and you put your name because now it's yours. And this is the typical mashup blog that you find with opinions of other people, but where you put your opinion. It's mostly from other people, but still it's from you. And you put this back to the web. What is the problem here? The problem here is that this content back to the web will reinforce the belief of this search engine that this content is good. So you are reinforcing not the order of the ranking, you are reinforcing the ranking function. And this is what we did more than 12 years ago with another one of my PhD students that also with Nive Siviani, where we found that the semantic redundancy was much larger, was 35%. And then you have the personalization problem, the filter bubble. I may know Alvin from a long time, and I can put in front of his screen whatever he likes, but I will never be able to show him something new that if he knew it, he liked it, because it's not in the data. So you get the massive effect. The rich get richer, and the poor get poorer. And what are the solutions? Which is like the problem of the Truman Show. The solutions are add diversity, add novelty, add serendipity, and I would like a 4th option that I still don't find it in any system. I call it my dark side. I want to see the most different user from me, not to see, for example, which news that person is looking at, but I want to see how different from me. I want to see the size of the universe because I think we have the perception that people is very similar to us, and every election shows that that's not true. So this implies that you have echo chambers in systems, not only for users, filter bubbles, but also for systems. Why? Because systems do short-term video optimization, basically short-term revenue. The system is partly writing its own future because of this exposure bias, this feedback loop system. And then if we don't explore enough, we don't know our world enough. So the system itself is also in a bubble that is creating itself. So it's basically a self-fulfilled prophecy. And there are some papers that have shown this. Last year was a paper in AAAI on the echo chambers of people. And I'm working on also the echo chamber of systems. Basically, you have a partial knowledge, and then you will have unfair e-commerce information markets as a result. Can we do better? Yes, we can do better, but we need to invest more time in exploration, and that means maybe lose some revenue for some time, but to get long-term improvements on the revenue. So what will be the rule is that you can do this if the new traffic that is coming to your site is greater or equal than the traffic that you need to approximate well the new world. And the new world is user changes, new items, and so on. Everything that is new that in your system. Large internet sites fulfill this condition. Otherwise, we will be living in a suboptimal solution. So we have some preliminary results with Giovanni Del Nevo, and here we try different exploration algorithms, and we have the Oracle. The Oracle knows everything, so the Oracle knows exactly the world and knows exactly the CTR of every item, so click-through rate. And we found that basically using Thompson sampling is bad. It's like 3 times better than random only. And the best one of these 3 exploration algorithms was X3, which is the most recent one. Most people will use UCB, but still we're far from the Oracle. So this is the best we can do, exploring enough. But if you are doing greedy optimization, and maybe you are even doing less than optimal greedy, you will be like in 50%, much less. Okay, so to finish, very important, the web works thanks to bias. Thanks to engagement bias and self-selection bias, for example, caching works. And then if we do a recap, and here are all the different things that I mentioned, like statistical, cultural, quantitative bias, I have 2 question marks here. So if I give a system to just females or a project to just males, will I get the same system? So I'm talking about our professional biases. And these professional bias, they are very clear in the problems with choose. For example, we have a hype in big data, while most companies can only use small data. We have maybe biases encoded by the designers or the coders. And I will explain this experiment that they did in Virginia that is not about coding, but it's very similar to that. And also sometimes we have bias on the evaluation. We don't choose the right experiment, we don't choose the right data, we don't choose the right metrics, and many times we don't choose the right baseline because we want to do better. These are biases. So this experiment was to give a lot of data about a soccer tournament, and they asked the people, do referees expel more African Americans or not? So basically, there is racism in soccer, yes or no? And the answer was that 20 teams said, yes, we found racism. 9 said we couldn't find racism in the data. So the surprise is not that really they didn't agree. The surprise for me, and this is like a 70-page, very interesting experiment that is available on the web, is that the 29 teams did something different. So basically, they all did a different statistical test. Some people didn't use a confidence interval, so maybe they didn't know much statistics. Some couldn't prove it because they had a very good value, but the statistics, the confidence interval was too large, and so on. So this is the diversity of people doing things. So maybe the answer is true. Designers and coders will do a different system. So what we can do very quickly, we can analyze for bias, we can recollect more data in sparse regions of the problem. We have to take out basically sensitive attributes. We need to be aware of biases, starting with our own. We need to give more control to the user. We need to get more input while we are designing and implementing software. And in evaluation, please do not fool yourself. So the take-home message is be aware of your own bias. Try to stop this vicious bias cycle. Be aware of your privacy too. I didn't talk about privacy, but that's also related to when you have a lot of data that you give away to other systems, like your interaction. And there are many, many research problems here. So I can take some questions while you read these jokes.
Okay, great. Thank you, Ricardo, for that wonderful talk. So I'll turn it over to Mark, our Vice Chair of ACM Chicago, to go ahead and address the questions, ask you the questions, Ricardo.
Okay, we have 2 questions from Ka Yin Ho. First question is, as the ML algorithms have been trained with biased input for a long time, what can we do to correct the bias? Input more data with heavier weight on the minority data?
So yes, we can do that. So we can try to balance the data. But I would say the best thing that we can do is try to do what I show for clicks in search engine. Basically, try to debias or to mitigate the bias on the input data. Other possibility will be to, for example, to do the machine learning with different weights, and that will be a case of tuning the algorithm, to tuning the model to avoid bias. And there's a lot of work on that. So, but the first thing is that you need to know what is the bias. And measuring bias is not an easy problem if you don't know what bias you're looking for. So it will depend a lot on what kind of bias you're dealing with.
Okay, and the second question is, as the biases have cascading effect, have you looked into correcting which bias might bring a larger impact on minimizing another bias or adversely expanding the bias?
Yeah, this is a very good question. So this diagram of cascading effect is mine. I was published 2 years ago, and I still don't know any research on that. So there's a completely new problem. For example, what would be the right A/B experiment, A/B testing experiment, for example, to isolate different biases and to see what are the effects of composing those biases. I'm working on exposure bias because I think it's the main one. So exposure bias has a really huge impact, so I would say it's the number 1. But for example, of all the other ones, maybe position bias is the next, but I'm not sure because there's no research on that.
And we have another question from the audience is, do people actually think that activity on the web represents the wisdom of the crowds?
Good question. No, I don't know if I had the title of my paper when I put that. I did believe in the wisdom of the crowds at some point, but after that, that research, I say that is the wisdom of a few. And this is not new. Always in the world has been the wisdom of a few because not all people participate. And I forgot to mention, there was a line that in 2006, Jacob Nielsen proposed this participation inequality rule that he said that 1% of the people did things, 9% of the people basically interacted with those things, and 90% of the people was just watching. He called them lurkers. Well, according to my results, it's much less than 1%. For example, in Twitter, if you take only the 50% of the content, let's say that means that is like 0.2% of the people. So it's much less.
And for our final question from the audience is, do the big internet companies, are they actually interested in diversity of views, or are they more interested in conforming views?
That's a very good question. I guess that's a question for the sociologist. I would say that let's be optimistic. I would say that they are worried about the problem and they're trying to solve it. But every time you see that they're trying to solve it, they doesn't seem to know how to solve it well. For example, how many ethical boards there are. So there are very few companies that have a very strong ethical board, or for example, checking functionality, new functionality, or new projects, or which experiments they will do in their system and so on. For example, every A/B testing experiment should go to an ethical board in a company, and that's not happening today. That will slow down them so that they will not do that.
And we have another question, one last question from Hamid Al-Huri. Given that bias can come from many things, how much can be done to reduce bias given that the evaluation could be biased?
Well, yeah, it's the chicken and the egg problem. I would say that the only way is to basically what I put at the end of what we can do. Do not fool yourself. So first thing is that so you can use the approach. So one thing I will do is to use the approach of this example I mentioned about the professional bias. If you want to be sure about evaluation, don't give it to just one team. Give it to more teams. So you try to do first a distributed approach to the problem, and then you will get different answers, and then you will let people to agree on those answers. And at least that will lower the probability of having like too much bias. That will lower the bias because you have considered different views. So for example, you can have a group of women, a group of people coming from Asia, a group of people coming from Europe, a group of people coming from the US, and then you have different points of view, and then you try to have one single agreement on that. And that's why, if you think, that's why we have reached to things like human rights. This is how the United Nations work. We try to reach consensus in the world to get to do these things.
Okay, great. Well, thank you very much for all those questions. So to conclude, let me just share my screen here. Okay, can everyone see my screen?
Yes, I can see your screen.
Okay, very good. Okay, so we actually have a webinar tomorrow. So we have a chapter which is Chicago CHI, which is the computer-human interaction. They're talking about HCI stuff with ACM, as part of ACM and as part of our ACM Chicago as well. And Victor Matavici, he is the chair of this Chicago CHI. So I'm not sure if is Victor on the line? Okay, let me see if I can. So Victor, can you maybe talk about just briefly about tomorrow's webinar?
Sure, can you hear me?
Yes.
So tomorrow we have an awesome talk. It will be Yas Brooks, and they will talk about this system that they developed that allows you to smell in VR. So as you go in these experiences, you know, there is always the question about how can you add more senses, and they developed this the system that now allows you not only to see objects in 3D and move around them, but also have the sense of smell. And yeah, it's going to be tomorrow.
Okay, then, great, thank you. And there's the meetup, the link, so you can go to our ACM Chicago meetup group and you can register from there. So our next ACM Chicago talk is going to be on Wednesday, October the 21st, so just before Yeah, so October 21st. And so
I can talk about this. We had some audio, but it's not coming through. But so our next speaker is someone who I saw at a string quartet. They gave a series of webinars this summer called the Floating Lounge, and Sam was a speaker there. He was playing all of his favorite music that he listened through the years, and I thought, like, this is a great speaker. We really need to get him. I know I started off in my interest in computers came right from what you're saying, which was computer music and electronic music. That was my gateway. So it immediately appealed to me. Sam teaches at University of Chicago, but he's also a well-known composer, improviser, and electronics performer. He's had his works recorded. If you look for him on Spotify, you'll see lots of recordings that he's on and where other groups have played his music, which include numerous string quartets, numerous new music ensembles, and a little known group called the New York Philharmonic. So he's going to be our guest next month. I think this will be a great meeting. Not only will he be talking about his work and showing his code, sharing his designs, he'll also be performing live from his studio. So I hope that all of you can attend. I think it'll be a great presentation. And if you go to our site, you can see numerous links, audio and visual, so you can learn more about him, his music, how he works. I hope you do that. Thanks.
okay, great. Thank you, Mark, for that. Yeah, so as Mark said, you can register for this right now. So that is for October the 21st. And like Gina mentioned about earlier in the beginning of the presentation, IEEE Chicago, we are actually celebrating our 126th anniversary. So we are actually the kind of after New York or so, we are the next kind of city or so that has been quite a long time in the IEEE realm space. So we're celebrating 126th anniversary. Obviously, because we cannot be there in person, so we're going to have a virtual expo and fair. It's going to be this Saturday. It's going to be from 9 a.m. to 3 p.m. So if you don't know IEEE Chicago, this is a great way to learn what IEEE Chicago does, what the activities the section and the societies do, including our own IEEE Computer Society represented here tonight. We are going to have keynotes, we're going to have speakers, we're going to have Q&A with the different societies like Vehicle Technology Society, Computer Society, Magnetic Society, and other societies as well. We're actually going to have a social that we're going to play. So that'll be very interesting. And we have prizes to give away. So if you attend or so, you might have an opportunity to win something. So details and registration are at IEEEchicago.org/anniversary. So please go visit that site and register for this Saturday. And then finally, for our IEEE Computer Society Chicago members, we are proud to be sponsors of FutureCon. So FutureCon is a event company that does a lot of cybersecurity conferences. They actually had one in Chicago in March, just before the lockdown of COVID. And so we were there before, but now they're holding the cybersecurity conferences virtually. And of course, cybersecurity is an very important topic in the computer industry. So that will be Wednesday, October the 7th from 10 a.m. To 6 p.m. Chicago time. So the members, you can register at the link that's over there. And there is a code that you can use that will give you a complimentary pass to be able to attend that virtual Central Cybersecurity Conference. Okay, so with that, we come to the end of the webinar this evening. Again, I'd like to thank you. I'd like to thank you all for attending this evening. I also definitely want to thank our ACM distinguished speaker, Ricardo Baeza-Yates for a wonderful, fantastic talk. This talk is being recorded, so we will send you the recording to this talk as well as the slides. And with that, thank you very much for attending. Please attend our next IEEE and ACM Chicago talks that I mentioned earlier. And everyone, have a good night, have a good evening, stay healthy and safe. Thank you.
Thank you. Bye-bye.
Okay.
Thank you, Rob. Thank you, Ricardo. Great, excellent talk. Thank you.